Hello everyone, myself Anubhav Dwivedi welcoming you all in the video lecture of fluid mechanics at the AKTU digital education platform. In this lecture, we will be discussing about the types of fluid and pressure and its measurement. We will move like we will have the glance on the topics covered in the previous lecture, viscosity, then Newton's laws of viscosity followed by types of fluid and pressure and its measurement. In the previous lecture, we have been discussed introduction to the fluids, that basic concepts, important properties of the fluids and surface tension and capillarity. Now, we will have the look on the capillarity in detail. So, as we know, capillarity is the phenomenon of rise or fall of liquid surface in fine tube, means we have two figures here having two containers, one is containing water and other is containing mercury. We see there is a tube which is inserted in the water as well as in the mercury. Here is the rise of water and here is the fall in the tube. So, now we have to understand at what situation, at what time this takes rise and when it gets falls. So, let us understand, if cohesion is less than the adhesion, the liquid in tube will rise, and vice versa. If cohesion is more than the adhesion, means cohesive force is greater than the adhesive force, then the liquid in tube will fall. Let us understand why it happens. Here adhesive force is larger than the cohesive force, means we can see this fluid tends to stick with the surface of the I can say wall of the tube. So, what does it mean? It means this tube and this water which get sticks with each other lifting the water, and due to the atmospheric pressure which is acting here at this point, this tends the fluid to move in the forward direction. So, it will take rise, and in the other condition in the mercury, we can understand cohesive forces is more, means the intermolecular forces between the molecules of two mercury. Okay. So, this will tends to move this in this direction and hence the fall taken place. Now, we will understand the same concept mathematically. Okay. We have taken H is the rise or fall, we have understand D is the dia, sigma is the surface tension, and then we understand the sigma surface tension force per unit length and length of meniscus is pi d. As we can say, this is the sigma which is the surface tension force and which is acting on this tube, means this tube must have some length of the per unit length of this dia of the tube. Okay. So, that will be pi d as we know. So, the upward forces must be equal to the downward forces for the equilibrium condition. So, therefore, for considering the upward forces, we will see sigma which is acting at the angle of theta will have the upward force pi d sigma cos theta. Why pi d is multiplied? Because we have considered the sigma, the tension force per unit length, okay, and here the length is what? Meniscus, okay. So, that we have taken upward force as pi d sigma cos theta. Now, for equilibrium, as we all know that upward force must be equal to the downward force, and the downward force is weight of the liquid, okay. So, which is acting in the outward direction. So, weight of liquid will be what? Mass into the acceleration due to the gravity. Now, for the mass we can write rho into V in place of mass, which is density into the volume in multiplied by the acceleration due to gravity. While equating these things, we can see that here rho into V is the area. So, we will multiply pi d sigma cos theta is equals to pi d square by 4, which is area into H into rho into G. Okay. So, we will get the value of H, and H is what? It is the height of rise or fall. Okay. So, if tube is entirely clean for water, in glass theta will be 0 degree and for the mercury theta will be 140 degree. Okay. So, here we have seen that how the rise or the fall in the tube can be calculated. Moving further, now we will discuss viscosity in detail. The resistance which is provided by the layers of the fluid, we will have the look in the detail. We can understand as the viscosity is the resistance provided by the movement of one layer of the fluid to the movement of the other layer, and which is termed as viscosity. If we have the movement of layer as shown in the figure which you can see here right now, as shown in the figure, if we see the bottommost layer having the velocity 0, the bottommost layer having the velocity 0 and the topmost layer will have some velocity. Okay. So, obviously we can say the velocity at the bottommost layer is 0, and when two layer of the fluid is at a distance dy apart from each other, means we have taken this distance what we have taken dy. Okay. So, let us suppose this is the distance between the two layers, and this layer which is below is moving with the velocity u and this layer is moving with the velocity u plus du. So, we can say that the top layer causes a shear stress on the adjacent lower layer, while the lower layer causes the shear stress on the adjacent top layer, and this shear stress which is caused by the adjacent layers must be proportional to the change in the velocity with respect to the y, which must be equal to the change in the velocity with respect to y. Now, let us understand what is the rate of change in the velocity with respect to y. Mathematically, how we can prove this? Mathematically, we can write that tau is equals to mu into du by dy, where mu is the constant of proportionality. We have understood this thing in viscosity also, that mu is the dynamic viscosity, or we can say coefficient of dynamic viscosity, and du by dy represents the rate of shear strain. Means we can understand this term as the velocity gradient. So, what will be the value of mu from here? We can easily see mu means the viscosity. The coefficient of dynamic viscosity must be the defined as the shear stress required to produce unit rate of shear strain. Means this is the shear stress which is required to produce the unit rate of shear strain. So, this way we can understand the viscosity in detail. I have explained here the dynamic viscosity, and now we will understand kinematic viscosity. Now, let us see what is kinematic viscosity. Kinematic viscosity is defined as the ratio between the dynamic viscosity and the density of the fluid. Mu we have understood, it is the dynamic viscosity. We can understand this as a dynamic viscosity. Now, this rho we know is the density. So, we can write that the ratio of dynamic viscosity to the density of the fluid can be termed as the kinematic viscosity. Now, there is a concerning of the viscosity, there is a Newton's laws of viscosity, according to which according to the Newton's laws of viscosity, the shear stress which is termed as the tau on a fluid element layer is directly proportional to the rate of shear strain, which we have seen while we are discussing the viscosity conditions. So, here we can see again mu is the constant of proportionality which has been used and known as the coefficient of dynamic viscosity. So, the fluid which will obey this relationship, means the fluid which will be the proportionality, having the proportionality with the velocity gradient, will be called as Newtonian fluid. Otherwise, the fluid which do not obey will be known as non-Newtonian fluid. So, the simpler condition of to understand the Newtonian fluid and non-Newtonian fluid, we can understand by this relationship. The fluid which obeys is simply can termed as Newtonian, otherwise non-Newtonian fluid. Let us have detailed understanding of the types of fluid. So, there are some other types of fluid apart from Newtonian and non-Newtonian. The fluids are classified into the 5 types which are majorly here we can see. There is a ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid and ideal plastic fluid. So, what is ideal fluid? We can see the fluid which is incompressible, means the density is not changing and having no viscosity, is known as ideal fluid. So, students, we do not have any type of fluid which is having no viscosity. All types of fluid contain some viscosity. So, what we can say? We can say that ideal fluid is only an imaginary fluid, as all the fluids have some viscosity. So, in real world there is no ideal fluid exists. Now, let us come on the real fluid. Let us understand what we are having a real fluid which possesses some viscosity is known as the real fluid. So, we all know in our day to day life, in daily practices, we have the fluids which are real. So, we can say आपके पास जितने भी टाइप के फ्लूइड्स हैं वो सारे के सारे रियल फ्लूइड के अंदर आ सकते हैं। आइडियल फ्लूइड में चूंकि विस्कोसिटी नहीं होती है और हमारे पास कोई भी ऐसा फ्लूइड नहीं है जिसकी विस्कोसिटी 0 है, तो हम कह सकते हैं आइडियल फ्लूइड इज एन इमेजिनरी फ्लूइड वेयर एज रियल फ्लूइड एग्जिस्ट। नाउ let us again understand what is the Newtonian fluid. Okay, a real fluid in which shear stress is directly proportional to the rate of shear strain, or the shear strain can also be known as velocity gradient, and this is known as Newtonian fluid. In case of non-Newtonian fluid, a real fluid in which the shear stress is not proportional to the rate of shear strain or velocity gradient, and this type of fluid is known as non-Newtonian fluid, means which does not obey the tau is equals to mu du by dy, means we can say for the case of non-Newtonian fluid tau must not be equal to what, mu into du by dy. So, this type of fluid can be termed as non-Newtonian fluid. Now, let us understand the ideal plastic fluid. What is ideal plastic fluid? This time I am just telling you by the definitions. Now, after that we will have the look on the graph, and by the graph we will come to understand what graph says about this type of fluids. So, first of all let us know by the definition of ideal plastic fluid, a real fluid in which the shear stress is more, that the yield value of the shear stress is proportional to the rate of shear strain or the velocity gradient is known as ideal plastic fluid. Now, what I have said, let us understand this thing by looking into a graph. So, have look on this graph. Okay. So, here this x axis shows the velocity gradient, means du by dy, here shear stress in the y axis. So, we can see the fluid which is ideal means having 0 shear stress, and why the shear stress 0? Because viscosity is 0, and if the viscosity is 0 then du by dy will have some value and the shear stress will be 0. At the same time, in case of ideal fluid, the shear stress, in case of ideal fluid we can have a look, there is a value of the shear stress. Okay. So, we can see which is incompressible and having no viscosity is known as ideal fluid, and which is having some viscosity is known as real fluid. Okay. So, if the viscosity is 0 means having no viscosity, what does it mean? We can say this is ideal fluid and which is imaginary, but in case of real fluid is possess some viscosity. By the graph we can see it. We can see the Newtonian fluid which is directly proportional, means a straight line is going. So, it shows that the tau is directly proportional to the mu du by dy. Okay. Now, have look, du by dy was 0 and then the graph was going upward direction, and that was the real ideal solid it is, and it was ideal fluid as I told you earlier. Now, let us have look on the ideal plastic. In case of ideal plastic, it has some value of shear stress which is I told you that above the yield limit. Okay. So, this graph starts from here due to the same reason, but in case of non-Newtonian fluid we can see this does not obey, means tau is not directly proportional to the du by dy. That is why we can see the curve in the graph of non-Newtonian fluid. So, by this we can understood the types of fluid and their relationship between the du by dy means the velocity gradient. Now, we will understand pressure and its measurement. So, before going to the measurement of the pressure, let us understand what is pressure and what is the pressure of a fluid when it is inside any fluid at the rest. Okay. So, we will understand what is the pressure variation in a fluid at rest, and this same thing can be also termed as hydrostatic law. Okay. So, here we have a point inside a liquid. The pressure at any point in a fluid at rest is obtained by hydrostatic law. And what is hydrostatic law? Hydrostatic law states that the rate of increase of pressure in vertically downward direction must be equal to what? A specific weight of the fluid at that point. So, we will have the derivation of the hydrostatic law right now here, and by that you will come to know that how this statement will be fulfilled. Okay. So, here if we have a point inside a liquid, this is the free surface of the liquid we can see, and we have the point inside a liquid, and just take the elementary volume near the point like this, we can say the shaded portion, it is the elementary volume having the face A, B, C and D. Okay. So, if delta A will be the cross section area of element, and what is the cross section area of the element? How the cross section area can be understood? This you are seeing from the front view. Okay. If we will look at the top view, we will have this as something like this. Okay. So, you can see this shaded portion from the front view. Now, if you will draw like this, then this portion at which the vertical force in the downward direction acting, this portion can be termed as delta A. And why it is delta A? Because this is the area of the top portion of the elementary volume. Okay. So, we can term it as the delta A. Delta Z is what? Height of this column, height of this element. Okay. So, we can write the height of this element is what? Delta A, delta Z. And pressure on face AB, this face contains some pressure and which can be termed as P from the above portion, means we can see which is acting at vertically downward direction, and Z is the distance of the fluid element from free surface, means from this free surface to this distance we will have Z. Okay. So, up to here this can be termed as Z. Now, we will have look to make this body into the equilibrium, we will have some forces which are acting on this element. And what are those forces? Those are the pressure forces from all over the direction which are acting on this fluid element. So, let us have look on the pressure forces on the different faces. So, at the AB, I have told you, which is acting vertically downward, the pressure force on AB is equals to what? P into delta A. Why P into delta A? Because pressure is acting P, and when we find the force, means force will be equal to pressure into area, and area of this element is delta A. So, we can write pressure force is equals to P into delta A, which is acting in downward direction, Okay. Now, pressure force as CD from the bottom also we will look, since it is at the some point and the fluid is containing below this also, then that will contain some pressure at the from the below. Okay. So, that force, pressure force from the CD we can understand. Now, look what is the value of that. Okay. So, students, let us understand from where this term came. Okay. Means del P by del Z is what? Del P by del Z is means the change in the pressure, all over this length, the change in the pressure with respect to the Z. Okay. All over this length, and for all over this length we will have to multiply this term into delta Z. So, हम समझ सकते हैं कि हमारा एक तो प्रेशर यहाँ पे P था ही, और जब हम नीचे की तरफ आ रहे हैं तो हमने देखा कि इस जो ये नीचे से जो प्लेन है, यहाँ पे जो चेंज ऑफ प्रेशर है विद रिस्पेक्ट टू द Z, और कहाँ पे? ऑल ओवर द लेंथ. तो हम लिख सकते हैं दैट प्रेशर विल बी P प्लस del P by del Z into delta Z, and this since multiplied by del A. Why it is multiplied by del A? Because all over the length तो है ही, लेकिन आपने देखा कि अगर ये सरफेस जो डेल्टा A एरिया कंटेन करता है ये नीचे भी तो होगा, तो जब ये नीचे होगा तो वी विल मल्टीप्लाई दिस विद डेल्टा A. सो हमने समझा कि प्रेशर फोर्स AB पे क्या लग रहा है जो वर्टिकली डाउनवर्ड डायरेक्शन में आ रहा है, एंड वी हैव ऑल्सो सीन व्हाट इज द प्रेशर फोर्स ऑन फेस CD, okay, which is acting vertically upward. Now, there is one more force which is acting on this element, and that force is due to its weight. इसके वेट की वजह से एक फोर्स जो भी डाउनवर्ड डायरेक्शन में ही लग रहा होगा, क्योंकि आपको सबको पता है कि वेट हमेशा डाउनवर्ड डायरेक्शन में ही एक्ट करता है, तो वो वेट W की जो वैल्यू आएगी वो हमारा डाउनवर्ड डायरेक्शन में ही आ रही होगी, और वी विल टेक दैट वेट इज इक्वल्स टू रो इंटू G इंटू वॉल्यूम. हम डेंसिटी लेंगे उस एलिमेंट का, उस फ्लूइड का डेंसिटी हमने लिया, हमने उसको मल्टीप्लाई किया एक्सेलरेशन ड्यू टू ग्रेविटी के साथ और वॉल्यूम, तो हमें मिल गया क्या? ये दोनों टर्म जो मिलके क्या बनाते हैं? मास. और ये टर्म जब मास जब G से मल्टीप्लाई होता है तो क्या बन जाता है? बन जाता है वेट. अब हम देखेंगे कि वॉल्यूम क्या है. तो वॉल्यूम एज वी ऑल नो, इफ वी विल मल्टीप्लाई the surface area means we can say the cross sectional area into the height of the fluid element, then that will become the volume. So we can write here it is the volume. So we can see the weight, the value of the weight will be equal to rho into g into volume, and volume means del A into del Z. और ये कैसे आया है I have discussed here. ठीक है, now we will move further. So students, now look one more thing. आपको यहाँ पे एक तो आपने देख लिया कि अपवर्ड डायरेक्शन से क्या फोर्स आ रहा है, और एक आपने देख लिया डाउनवर्ड डायरेक्शन से क्या फोर्स जा रहा है. अब आपको एक और चीज़ देखनी है कि इसके दोनों तरफ से भी तो फोर्सेस लग रहे होंगे भाई. ये इक्विलिब्रियम में है तो राइट हैंड साइड और लेफ्ट हैंड साइड दोनों जगह से फोर्स आ रहे होंगे. एंड व्हाट इज दैट फोर्स? दैट फोर्स इज कैंसलिंग विद ईच अदर, क्योंकि जो इक्विलिब्रियम में है तो जो फोर्स लेफ्ट से जो फोर्स राइट से बोथ आर इक्वल एंड अपोजिट. सो वी कैन से दैट द प्रेशर फोर्स ऑन सरफेस BC एंड AD आर इक्वल एंड अपोजिट, एंड हेंस इट कैन बी कैंसल्ड आउट. तो वी हैव फॉर द कैलकुलेशन ऑफ del P by del Z वी हैव दिस फोर्स जो ऊपर से लग रहा है यानी P इंटू डेल्टा A माइनस करेगा इस फोर्स के साथ जो नीचे से लग रहा है यानी P प्लस del P by del Z इंटू Z del Z इंटू del A. ठीक है, ये फोर्स इससे माइनस कर रहा है. अब देखिए जो हमारा वेट है वो भी तो डाउनवर्ड डायरेक्शन में ही ऐड कर रहा है, तो हम उसको एडिशन के टर्म में ले लिया हमने रो इंटू जी इंटू वॉल्यूम यानी del A इंटू del Z. तो हमारे पास एक इक्वेशन आ गई. अब जब हम इस ब्रैकेट को ओपन करके मल्टीप्लाई कर रहे हैं दिस बोथ टर्म विल बी कैंसल्ड आउट. ये जब दोनों टर्म कैंसिल हो गया तो हमारे पास बचा ये टर्म. ठीक है, और इस टर्म से हमने देखा कि हमारे पास del Z और del A बोथ द राइट हैंड साइड और लेफ्ट हैंड साइड दोनों जगह पे है. तो हम क्या कर सकते हैं, इसको सिंपली स्ट्राइक ऑफ कर सकते हैं. और जब हमने स्ट्राइक ऑफ किया तो वी हैव सीन del P by del Z मस्ट बी इक्वल टू रो इंटू जी. अब आप देखो एक चीज़, del P by del Z जो है वो वेट है यानी वेट डेंसिटी ऑफ द फ्लूइड, और ये जो वेट डेंसिटी कहाँ से आया है, ये रो इंटू जी से आया है. तो रो इंटू जी कैन बी टर्म्ड एज W स्मॉल w विच कैन बी अंडरस्टैंड. तो del P by del Z इज वेट डेंसिटी. तो हमने क्या देखा यहाँ पे, हमने देखा कि द रेट ऑफ शेयर स्ट्रेन मतलब वेलोसिटी ग्रेडियंट किसके इक्वल है, वेट डेंसिटी के. और स्टार्टिंग में आपको क्या बताया था कि वी हैव टू प्रूव दिस थिंग इनटू द हाइड्रोस्टैटिक लॉ. So above equation states that the rate of increase of pressure in vertical direction is equal to the weight density, and hence it is proved, and it is only known as hydrostatic law. Now after the hydrostatic law we can see from where this relation comes. That equation which we get from the hydrostatic law it will be integrated. अगर हमने उसको इंटीग्रेट कर दिया तो इंटीग्रेट करने के बाद हमें जो प्रेशर का रिलेशन मिलेगा यही मिलता है रो इंटू जी इंटू जेड, और इस जेड को हम एच भी समझ सकते हैं. क्यों? क्योंकि ये हाइट फ्रॉम फ्री सरफेस है. तो आपने देखा होगा जो प्रेशर का हमारा रिलेशन होता है रो इंटू जी इंटू एच, वो कैसे आया, वो यहीं से आया, हाइड्रोस्टैटिक लॉ के इक्वेशंस को हमने इंटीग्रेट कर दिया. नाउ द लास्ट थिंग विच वी हैव टू डिस्कस इज द डिफरेंट सिस्टम टू मेजर द प्रेशर. कि हम प्रेशर को मेज़र करने के लिए डिफरेंट कौन कौन से सिस्टम्स का यूज़ करते हैं, कौन कौन से हमारे पास डिफरेंट प्रेशर्स होते हैं जिसका यूज़ करके हम उसको मेज़र आउट करते हैं. तो हमारे पास एब्सोल्यूट प्रेशर होता है, गेज प्रेशर होता है, और एक होता है वैक्यूम प्रेशर. वी विल लुक इनटू द डिटेल ऑफ दिस. कैसे? एब्सोल्यूट प्रेशर, देखिए अगर आपके पास कोई एलिमेंट है, मान लीजिए यू हैव दिस एलिमेंट विच इज़ डेटम लाइन. ओके, अभी आप एटमॉस्फेरिक प्रेशर से इंट्रोड्यूस नहीं हुए हैं, आपके पास एटमॉस्फेरिक प्रेशर से इंट्रोड्यूस आप नहीं हुए हैं, तो उसके नीचे जो भी आपके पास प्रेशर, मान लीजिए आपने एटमॉस्फेरिक प्रेशर ये है आपने इंट्रोड्यूस किया, उसके बाद आपको जो भी प्रेशर की वैल्यू मिलेगी वो हमारी फ्रॉम प्रेशर ज़ीरो से आएगी, तो वो हम कह सकते हैं एब्सोल्यूट प्रेशर. तो इस बात को हम कैसे टर्म फ्रेम कर सकते हैं, इस बात को हम फ्रेम कर सकते हैं कि इट इज़ डिफाइंड एज द प्रेशर which is measured with reference to the absolute vacuum pressure. Okay, now gauge pressure, it is defined as the pressure which is measured with the help of pressure measuring instrument. मतलब कि हमारे पास एटमॉस्फेरिक प्रेशर के ऊपर कुछ प्रेशर है जिसको हम मेज़र करने के लिए किसी इंस्ट्रूमेंट का यूज़ कर रहे हैं, और उस इंस्ट्रूमेंट से जो प्रेशर की रीडिंग आएगी उसको हम कह सकते हैं ये डायल गेज की रीडिंग ही गेज प्रेशर हो जाती है. तो वी कैन अंडरस्टैंड द रीडिंग विच इज शोन इन द डायल गेज इज गेज प्रेशर. अब वैक्यूम प्रेशर क्या है, देखिए आपके पास एटमॉस्फेरिक प्रेशर यहाँ था, आपके पास एब्सोल्यूट प्रेशर ये था और ये था गेज प्रेशर तक की वैल्यू। तो अगर आप जानते हैं कि यहाँ पे प्रेशर जीरो नहीं है, क्योंकि प्रेशर जीरो तो यहाँ है, तो इसका मतलब कि यहाँ पे कुछ वैल्यू होगी ना प्रेशर की, जो कि बिलो एटमॉस्फेरिक प्रेशर होगी, तो वही वैल्यू हमारी हो जाती है वैक्यूम प्रेशर। तो स्टूडेंट्स, अगर हम इसी बात को मैथमेटिकली रिप्रेजेंट करना चाहें तो हम लिख सकते हैं कि एब्सोल्यूट प्रेशर इज इक्वल्स टू एटमॉस्फेरिक प्रेशर प्लस गेज प्रेशर। ओके, लाइक एब्सोल्यूट प्रेशर इज इक्वल्स टू एटमॉस्फेरिक प्रेशर प्लस गेज प्रेशर। और वैक्यूम प्रेशर क्या होता है? एटमॉस्फेरिक प्रेशर माइनस प्रेशर एब्सोल्यूट, मतलब जो एटमॉस्फेरिक प्रेशर से नीचे का जो प्रेशर है, मतलब अगर आप इस पूरे में इतना माइनस कर देंगे तो ये जो वैल्यू आपको रीडिंग आएगी दैट विल बी द वैक्यूम प्रेशर स्टूडेंट्स। ओके, सो आज के लेक्चर में हमने ये सारी चीज़ें देखी। वी हैव अंडरस्टूड वन मोर थिंग दैट इन द वैक्यूम प्रेशर we have seen the pressure which is above the absolute pressure and below the atmospheric pressure। तो अगर हम इस चीज़ को समराइज करना चाहें तो हम क्या कर सकते हैं? हम ये कह सकते हैं कि we have understood in today's lecture that there is a different relation of the pressures. What is the hydrostatic law which we have understood, and how the relationship that is rho is equals to P is equals to H rho G came from, and also we can understand that what are the types of the fluids. Okay, so today we have seen the types of fluid and what is the Newtonian fluid, what is the non-Newtonian fluid. Newtonian fluid, once again I am telling, which obeys the Newton's laws of viscosity. Okay, means what? Tau is directly proportional to shear strain rate, means velocity gradient, that is du by dy. और non-Newtonian में क्या हो जाता है? Which do not obey that Newtonian law, means what? Tau is not proportional to that velocity gradient, so that will be non-Newtonian fluid. We have also seen ideal fluid, we have also seen ideal plastic fluid and the real fluid. One more thing which is has to understand and taken care of कि जो हमारा ideal fluid होता है वो exist नहीं करता है, real fluid हमारा exist करता है। क्यों? क्योंकि कोई भी ऐसा fluid हमारे पास नहीं है जिसकी viscosity 0 हो सकती हो। तो in today's lecture we have seen the types of fluid. Also we have started with the capillarity, means the understanding of the capillarity in relation with the adhesive and cohesive forces, कि किस केस में हमारा कोहेसिव फोर्स जब ज़्यादा हो गया, मतलब कि दो फ्लूइड के अंदर का जो इंटर मॉलिक्यूलर अट्रैक्शन है वो जब बढ़ गया तो उसको टेंड करेगा अपनी तरफ खींचने के लिए वाटर, और उस समय क्या होगा कि फॉल करेगा वाटर कॉलम, मतलब ट्यूब के अंदर में फॉल करेगा, और इन अदर केस वो वॉल से स्टिक होगा और राइज करेगा। So students, I hope that you have understood these things. We will move with other topics in the next lecture. Thank you very much.